didn't know how to flip, so I'm not going to do that anymore. This is our CAD lab here at IVCC, very empty, sadly very empty. It's going to be very empty all summer. There will be some blended classes in the fall. That means that the lectures will be delivered online, and the labs will be open labs where you can come in and get help, okay? So those of you who are interested in CAD, it's a good, kind of a good thing. We've got a program now. If you take 4 classes, it's AutoCAD Beginning and Advanced and SolidWorks Beginning and Advanced, you get a certificate, and it's really good to add to your resume, and it's a good thing because a lot of manufacturers want somebody to know how to do CAD too. There's a lot of my students are coming from industry because their employers are wanting them to learn CAD. This is a workroom that we're going into here, and this is the good part about the 3D is that we have these wonderful machines, 3D printers. Ours are very industrial. They're not like the kind that people buy for $2,000 to $3,000 and put on their desk at home. They're made for industry, and they just do a whole lot more, a whole lot easier than what you do in a home one. You get to sometimes struggle with it. You might even know how to have to do some coding and things like this. This one, you just kind of push buttons, okay? These two here are what we call FDA, and they use different types of material, and I'm going to show you that material. But basically what 3D printers do are print just a one level at a time, and then it will move the tray and it will print again and again and again and again. And so basically it's printing in layers. And that's what these two do. Most of them do that, but there are some quicker machines out there that do it in a different way. This is our newest machine here, and I absolutely love it because not only can it do just plastic, but it also does a something that's called TPU. I'm going to get kind of close there. I mean, I don't know if you can see it because of that light, but it is going, and it is drawing this mask, which is some of the PPE that we created during the pandemic that people were missing. So I'll show you that in just a second. The type of material that this uses is in here. This is the softer TPU stuff that we're using, and this is what we call support material. So they basically can't draw on air, so whenever there is a space that isn't actually if there's nothing underneath it, they'll put a support material under it. The support material is soluble. We actually take it over to this little sonic cleaner over here, and it's filled up with bleach. Actually, it's not bleach, it's lye and water. It vibrates and heats it up until the support material comes off. The other type of machine that we've got is kind of like an inkjet printer, more like what we use at home. These are kind of like pen plotter printers that were around years ago. But this one, it uses a liquid polymer, and I've got it out here. This is a liquid polymer that we put in there, and underneath here, there's thousands of little holes, and it shoots the material out, and then the UV light comes back, and it will harden the resin, and we come out with some parts. I'll show you some of the things that we were doing during the pandemic. We created some masks. They're kind of cool. This one is that softer material, so this would be more comfortable. These I think I wouldn't use unless I really needed to. This one kind of looks like Darth Vader. I don't know if I can do this one-handed, but basically what you do is you use a regular furnace filter, and you get the best furnace filter that you can, and then you pop it in here. Like I said, I'm probably not going to be able to do it one-handed, and I'm not even in there, but this is what it will come and look like. And then of course you put elastic around there. These are shields that we created. The shields themselves actually are, sorry, you probably need this. Here again, I can't do this one-handed, but this is just overhead projector paper, and it pops into these little holes like this, and it protects the doctor and nurses from anything. And on the back here, we have that TPU has that I told you it's a stretchable material, and I can't really get in there, but here I'll do it like this. See how it stretches? So it's much more comfortable than elastic. And we actually gave 100 of these to the Veterans Home. We also gave them to the OB department at St. Margaret's because they have to wear safety glasses, and very hard to see out of safety glasses at peripheral vision. So they were really excited that they could wear these instead. Now this other machine, that one, the bigger machine, I showed you what the material looked like, and actually this is what it looks like over here. It's this, and the other machine comes in a cartridge. It's ABS material or ABS plastic. Why do we use 3D printers? Because first of all, you can rapid manufacture these. You wouldn't want to, do this for like $1 million or something like that because it's a little bit more costly than doing injection molding. But it's good for design. I always assign my students every year an assignment. Like this one was draw a unique cup, and then when they do this, then they can look at it and see, oh my gosh, this isn't going to work. And the big thing that didn't work there is you can't get your lips in there without drooling. So, and then another one was really cool. Years ago, I had students that wanted to do a project, and they said a can holder, and there were 3 engineering students. And I said, 3 of you are going to design a can holder, and it was pretty lame. I don't have it right here, but they did a really good commercial because they had to do a kind of a presentation. Well, I had another student. I would go, "This is the dumbest product we've ever made," and I had a student go, "I want to do that." I'm like, "Oh no!" Well, this is his end result here. And you see, it's kind of cool. Your drink's not going to get cold. Your hand's not going to get cold, and your drink's not going to get hot. And he actually got a temporary patent on that for a while. Didn't go anywhere, but that was our only product that never went to patent. You can see we can print things. I did make 6 or 7 ukuleles. I never did finish off the neck on that one. But they do work and they do sound okay. Here are some other things that we can 3D print. This is a pizza cutter. This is a cake cutter. I've come up with all different types of ideas. Okay. Now I'm going to take you into the drafting room, and this is the room that you would be in if you were on a face-to-face class. And you're going to hear a lot of this in the first, second chapters when you get them. But I'm going to start off right here. This is a drafting room. We do have computers in here, but basically you'll see that some of these tables, and see if I can get one, will, kind of work like an old-fashioned drafting table. Here is an well, it's not old-fashioned, but it is a portable drafting table. Some of the tools, and I'm just going to come on over here, some of the common drafting tools, and don't bother reading this. This is just kind of show you. Biggest thing, eraser and erasing shield, okay? We'll talk about the paper later. I didn't have any of these to get out, but usually a divider and a compass to draw circles, although we have circle templates. Here's circle templates, scissors if you might need them. We use different sized pencils, and we'll talk about that again. This is an older drafting machine. I used to work on them. I loved them. They were so much fun. And then we're going to be looking at different types of scales and a protractor. Sometimes people forget how to use them, but we'll tell you. Drafting tape to hold the drawing down, and a T-square. And a T-square just helps you keep straight. Other things, well, here's a protractor. Here's a circle template, and that was 3D printed. Here's one of the scales. There's really 3 or 4 different types of scales. Manufacturing is now moving into metric slowly at a time. So there's inch scales, metric scales, and then civil engineers use a different type of scale, and so do architectural engineers. We'll talk about that later in the semester. This is a T-square that helps us draw at different angles. See if I can get a better picture of it since it is clear. Not really. Okay, but you'll see pictures of those in your book. Now the next thing, well, one of the first things we do in engineering is sketching. You know, you're coming up with ideas, and sometimes it's just easier to sketch them out on a piece of paper. I have a backpack challenge every year with my students. They have 1 hour to come up with a really cool, different backpack. This one has a solar panel to charge your phone with. This one has a drink holder, a phone pocket. This one, it has a Bose system in it. And this one has a selfie stick, so all you gotta do is pull the selfie stick over, and you can take a picture of yourself with your GoPro as you're walking down the hallways, right? Okay, we even had ones that followed you around. A lot of times we'll do work for industries. Here we were helping a doctor out by making a layout of his office, and so we went to his office, measured, and gave him some good drawings. All right, so next thing I want to talk about is the size of the paper, and that's going to be one of in the first chapter. Okay, this is what we call A size. There are metric sizes too, but I prefer to stay with English because it works better on our printers, okay? So this is A size. This would be A4 if it was metric, but mostly we use English, okay? So A4, or A size, and if you double A size, see there's two of these here. If you double A size, you get B size. A size is 8.5 by 11. If you double the 8.5, you get 17 by 11. Okay, and then if you double that, if I take the B size and the C size, or the two B sizes, and this one I don't think was drawn quite right, but that would give me C size, and then if I double the C size, I will get D size. Sometimes we just, when we're working in the field, I like to see nice big, so we staple them together, or they can be folded really cool like this, so that they can come right down to an A size. And you'll see that in your book too. These are important things, but they're quick to learn too. All right, so the types of engineering drawings. Now this is what I want to point out. These two are civil engineers. This one came from the Illinois Department of Corrections. I do believe that they were just remodeling. And you'll see all this information on here, and this is what you're going to learn in this class, is what is all this information and how do I use it. This is called a title block, or a title strip, and it's got all kinds of things in it. Revisions are when they make changes. You should put who drew it and who appealed it. They took it off because they don't want to give out information like that. It was approved. It tells the name of the architects, and then it gives lots of information. The first sheet is called the title sheet, and then you're going to see some assemblies and things like that. And here again, don't panic because this is stuff you're going to learn in 8 weeks. These are section views, and we'll talk about that way later in the chapter. But what I want to point out is there's so much written information on these drawings, and that's what you have to figure out, is how does this affect me when I'm actually going to build something. Now, I don't think any of you will be doing civil engineering unless you go on for the 2-year degree. Then we do have people working at a lot of architectural places and civil places. This is an architectural drawing. You're kind of familiar with that. Here's a floor plan. Here's the elevation views. Here again, we'll learn in this class just what the notes mean, okay? And all right, so I did have one. Oh, okay. Now I have some mechanical ones, and they are actually ones that my students give out or make. This was one of the big challenges that we didn't get to do actually because the COVID assignment, but this is a fixture. If you're familiar with a fixture is, it was going on a CNC machine to hold down some plates. And this is called an assembly drawing. These are called dimensions, and these are called, this is called a bill of materials. Some of you might already be familiar with some of this. And this is a a full-scale section view of one of the little parts that they had to put together. These are called detail views, kind of sticking together here for me. But most drawings are made up of assemblies and details. The assemblies are what everything is put together. The details are what each part. So if you were a machinist, you would come in and draw that part, or make that part, that part, that part. These are the dimensions, and these are the identifiers of what part that is. It also gives the size, overall size of the stock, okay? So that's something that a CAD student had drawn, but it's something that you're going to have to be able to read and connect. Where is that drawing? How do I find that drawing? And what's it made out of? And how many do I need? Okay? So I'm hoping these pictures aren't too bad. This is a real quick kind of thing that my students put together. It was awesome. But this is what we're going to be learning. So don't worry. I'm just going to give you a quick shot of each one of these. They will come up in the book. Working drawings. That's what we just look at. Working drawings. We can call them blueprints. Some people call them white prints. Some people call them drawing packages. Some people call them working drawings, but they are all the same. Okay? And then the biggest part of it is the general assembly. Everything's all put together. The part list, it gives you all the parts that I have to gather to put it together. And we make assembly drawings. Details, that's where I do each individual part. The part list or bill of material. This is an example of an assembly drawing. This is an example of a detail drawing. And in the assembly drawing, we give some locations of where they're actually, you put these. Okay? And to go on, this is a detail drawing. So that's the very simplest type of drawing. And it's got dimensions on it and anything else that you need to actually put this together. Now this is probably the hardest part of the class, is learning the projection methods, because it's way different. We see things in 3D, but now we're going to start seeing things flat, okay? So we actually take something and look at it from different angles, at 90-degree angles. Straight down from top, front, bottom, left, right, and the rear, okay? We also have different line procedures. So each line has a meaning. It's called the alphabet of lines. You'll be learning about that quick. In the United States, we use what we call third angle projection. In Europe, they use first angle projection. You'll be learning about that. And here is a kind of a representation of this part right here in the actual 3D or orthographic projection of it. The top of it, actually it's not that, it's this. The top, the front, the right. Okay, this is called an isometric view. And then there's dimensioning, and dimensioning is so important, because if parts don't fit together, then we got to start from the drawing board. So dimensioning is very, very important. There are lots of rules. There's lots of different ways to dimension. Holes are dimensioned differently. And so dimensioning, we'll probably slow down on that chapter pretty much, okay? All right, I'm getting to the end here, especially since my battery thing just went up. Here's some kind of drawings that my students did. They were done on solid modeling. And here again, we have a title strip. We have a bill of material. I hope they're focusing pretty well here. If not, I'm going to have to come back and do this, but I just wanted you to get some information while you're waiting for your books, okay? I might send some references too. And as far as attendance goes, I'm pretty much expecting you to log in 3 times each week, and you will probably be spending time reading, and it's not a very hard course. I'm going to try to do some fun things too, like crossword puzzles and a Kahoot. Now, if you've never heard of a Kahoot, you're probably going to either hate it or love it, but it was some things I do in classes to actually make things a little fun. Okay, so anyway, I just wanted you to meet me and kind of show you around, kind of give you an idea what you're going to be doing in the next 8 weeks. And 8 weeks is a pretty quick time to go, especially during summertime. So what I would recommend, if I could flip back here, I would. Oh, Is that it? No, that's not it. But what I would recommend, how about I do this? I have no idea if I'm in there. But what I would recommend is that you set a set schedule, whether it be 10 in the morning, 8 in the morning, 10 at night, 2 in the morning, whatever is good for you. And if you need help, I can show you how we can do a Zoom or a FaceTime, and we can talk things out little by little. And seriously, if you do need to come to campus, we can set up some time where you can come to campus. We're limited, you have to wear a mask, and we have to keep a 6-foot distance and things like that. But if we're wearing masks, I think we'll be okay. And hopefully, if you have any more questions, please email me as soon as you can. Make sure you check your email every day in case something changes, okay? Good luck.